Hey everyone, so today we're going to talk about the pathophysiology of anaphylaxis. So what's going on in the body when someone experiences anaphylactic shock? So we should say first that anaphylaxis is an immune response that the body used to use against really serious parasites like worms. So what happens now is that this same response reacts to less severe invaders, things like pollen or shellfish or peanuts. So we call these invaders, or these things that the body is fighting against, we call them antigens because they generate antibodies. Okay, so in this specific case, we can refer to the antigen as an allergen because we're talking about an allergic response. So today we're going to talk about a very specific type of antibody that the body is going to produce in response to our allergen, known as an IgE. And let's just say quickly, so that we remember what antibodies do, they have a site up here that can bind this allergen, and we're going to use that binding site actually to help us trigger this immune response, and we'll get to that. So the reason these IgE antibodies are important to this conversation is because they can bind to immune cells that are really good at producing inflammatory agents like histamine. And histamine is what causes the swelling, it's what causes the hives, it's what causes the difficulty in breathing. It's inflammatory agents like histamine that are going to make anaphylaxis happen. So this is what we're going to do. We're going to talk about how an antigen or an allergen causes the immune system to produce IgE antibodies, which are going to be used to trigger an inflammatory response when that allergen comes into the body. Okay, so let's get started. So the first cell type that we're going to talk about is what's called an antigen presenting cell. Okay, and these things are just eaters of the immune system. They just eat anything that they see. So they're going to take up, let's say, some peanut protein, and it's going to break down that protein and put it up on its cell surface receptors. So it's basically saying, hey, immune system, I've eaten something, I have no idea what it is, come check it out. So the next cell type that's important in the process is called a helper T cell. Okay, these helper T cells, we should say, go through a really strenuous maturation process where they are geared up to react to a specific antigen or a specific allergen. So let's say this helper T cell is geared up to respond to peanut protein. That's just your genetic inheritance. You're going to produce helper T cells that respond to peanuts. Okay? So this helper T cell has an empty cell surface receptor. It's going to go check out what the antigen presenting cell has to offer, and if it can bind this, which in this case it's going to because it's geared up for peanut protein, it's going to go into full-blown pirate mode. Okay? It's going to say, whoa, 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 the immune system is experiencing something here. I need to go get some sort of other cell to produce some antibodies, because the helper T cell is not going to produce antibodies on its own. So now we turn to a cell type called the B cell. The B cell mainly produces antibodies. That's its wheelhouse. That's what it's really good at. Okay. So the B cell, like the antigen presenting cell, can take up antigens from the immune system, but with the one caveat that it takes up only specific antigens and allergens like the helper T cell. So let's say this B cell can respond to peanut protein. So it ingests a little bit, and it's going to start putting little pieces of the antigen up onto its cell surface. Now we should say B cells can produce antibodies on their own. So if this B cell recognizes the peanut protein and ingests it, it's going to start making antibodies against the peanut. But it's not going to be making IgE antibodies. It can make different kinds, IgA, IgB, what have you. IgE antibodies are important for this particular type of immune response. So what has to happen is this helper T cell, which has also been primed to respond to the peanut protein, right? This is the same guy. He's a little more lopsided now. This is the same guy as this one. He's going to come over. He's already been primed. He's going to say, whoa, B cell, I've reacted to this. You've reacted to this. I tell you what, why don't we get you to start making IgE antibodies instead of whatever else you're making, a little maniacal smile there, so that we can mount a really serious immune response against this allergen. So the B cell says, cool, let's do that. So it starts making these antibodies that are specific to, well, it's the other way, but starts making these antibodies specific to the peanut. And we should say quickly that the way that this happens, there's a communication chemical that's generally referred to as a cytokine. So there are a lot of different kinds of cytokines, but basically what this means is the helper B cell is able to communicate to the B cell so as to induce it to make these IgE antibodies specific to, in this case, the peanut. Okay, so IgE antibodies get released. And so they make their way into the bloodstream, and what they're going to do is they're going to affix to a certain type of immune cell that produces inflammatory agents. So this is called a mast cell, and this is called a basophil. So they both produce, as our color coordination is going to show us, histamine or inflammatory agents, right? And the mast cell, we can say, is found in the tissues. Basophil is usually found in the blood vessels and the circulatory system. So what's going to happen is these IgE antibodies are going to affix to the surface so that now, if the body encounters this allergen, it is going to produce more antibodies, but it can also cause an immediate response, which is it's going to cause these mast cells and basophils to do what's called degranulation. Basically means it's going to release its store of inflammatory agents. So let's say you eat a peanut, you don't know you're allergic, you've created this immune response. Next time you eat a peanut, these mast cells and basophils are going to get triggered when the antigen, the peanut protein, binds to that antibody, and these histamines, these inflammatory agents, are going to get released into the body. And when this happens, you get the swelling, you get the hives, you get the irritation, you get the closing off of the windpipe. So histamine has a lot of effects. The main effects it has is that it causes blood vessels to become leaky and dilated, and it causes the contraction of smooth muscle tissue. So that's why it becomes hard to breathe, because the windpipe is surrounded by smooth muscle tissue. So in order to combat the effects of the release of inflammatory agents, we need something called epinephrine. Okay, and epinephrine has the exact opposite physiological effect as an inflammatory agent. So it's going to cause blood vessels to contract, it's going to cause them to become less leaky, and it's going to cause smooth muscle to relax. So that's why people carry EpiPens if they know that they are susceptible to anaphylaxis. So that's an overview of how the immune system gets geared up to produce an anaphylactic response, and all the cell types that are used to mediate that response, and a discussion of epinephrine and how it counteracts the effects of the inflammatory agents that are released during anaphylaxis. Thanks for watching.